Hello and welcome everybody to this month's Department of Energy Python Exchange. My name is Cameron Riddell and I will be your host this evening, afternoon, or morning depending on the time zone that you live in. As you all may know, our goal here is to have Python thrive within the National Lab System and associated research sites. And in support of that goal, we are joined today by Dr. Stuart Campbell, who is a Chief Data Scientist and Deputy Program Manager for the Data Science and System Integration Team within NSLS-II. Dr. Campbell will be sharing on some of the projects and challenges he has encountered throughout his career, working at many world-class large-scale experiment user facilities in both Europe and the United States. But before we go into the agenda and introduce our panelists today, I wanted to remind everyone of a few key points about these exchanges. This call will be recorded, edited, and posted online. And as a consequence, we want you to be conscious of all of the information that you might ask in the questions to ensure that you're not accidentally sharing anything that's privileged or requires clearance. Additionally, as you all know, we are a growing community and we would love to stay in touch with each of you. If you would like to be kept up to date with our monthly exchanges, please sign up for our mailing list, which you can find on our website, meetup.doepy.org. You can additionally find recordings of all of our past exchanges on the site as well as a recording of today's exchange once it has been edited and of course posted. For those of you who have never joined us for an exchange before, I'd like to share with you that these events are typically broken down into 4 parts. First, we'll introduce our fantastic lineup of host and guest panelists so that you can all get to know them as well as their respective fields and backgrounds. Second, we'll kick off into a coding activity where I'll ask some very applied questions to our panelists to elicit some practical discussion about best practices in software development and where they fit into the world or the life of an academic or scientific researcher. Third, we'll turn things over to Stuart, who's going to share some prepared remarks on his career. Then, to wrap up, we'll have a full discussion about the points brought up by Stuart and see how these points fit into the life of our everyday researcher. For everyone joining us in the audience, this is your chance to ask questions and engage with our entire panel to help us understand where Python and these tidbits that Stuart is going to share with us fit into each of our lives. With that all being said, I would love to kick off today's exchange by introducing each of our host panelists. So behind me, you should see my screen, and I'll hide here in the corner. I'll even go ahead and double share my screen so you all can see everything that I'm seeing here. Our style of introductions are called Ask Me About, and we're going to go through and ask each of our panelists to share with us some portion of research or some portion that they find themselves to be an expert in, and we usually dress this up and say, what type of questions would you love to hear from the audience today? Because all of our panelists are very humble and might not even consider themselves experts, even though they are. But before we dive into all of our panelists, I wanted to share with you our link for meetup.doepy.org. This is where you can find all of recordings of all of our past events, as well as this event once it has been posted. Now, for our host panelists, I will start by introducing myself. Hello, everyone again. My name is Cameron Riddell, and while I'm not affiliated with a specific lab, I do have a background in academic research as I studied cognitive sciences in graduate school. And for today's exchange, I would love to address or discuss any and all questions relating to Python as a whole, as a language, or specific concepts and tools that we might encounter in Python's data stack. So tools like pandas, NumPy, and I love data visualization, so especially matplotlib. Now, for our first host panelists, we're also joined today by Tanny Chavez. Tanny, I see that you are from Lawrence Berkeley National Lab. Tanny, can you tell us a little bit about what it is you're an expert in, or tell us the types of questions that you would love to help us field from our audience today?
Hello, everybody. I am a computational research scientist at LBNL, and my field of expertise is mainly on data science and machine learning. What I would like to hear more about and answer questions about is how we can further integrate machine learning or data science-based pipelines within our data analysis workflows.
Thank you very much, Tania. I'm very happy to have you join us today. Next up, we are also joined by Dan Allen. And Dan, I see that you are at Brookhaven National Lab. Can you tell us a little bit about what it is that you're an expert in, Dan?
Sure, I'd be happy to take questions about building collaborative communities across different facilities, especially DOE labs.
Fantastic. Community building is a large part of honestly getting work done, so I'm very happy to have you join us here today, Dan. Next up, we have our guest panelists, and as you may already know, we are joined today by Dr. Stuart Campbell. Now, I mentioned earlier Stuart's title, and Stuart, I see that you're also at NSLS-II. Can you tell us a little bit about what it is that you do and what it is that you're an expert in?
Well, they're very two distinct things, I think. So I work in the same part of the organization as Dan does. So we are concerned with all basically the computational and data aspects with performing experiments. And so everything to do with, the computing at a facility like this. I'm not going to say I'm an expert, but the thing I've been playing with recently is writing web services with Python using fast API. So that's something I've been burying myself into recently. So
fantastic. Well, Stuart, I'm very excited to hear what you have prepared for us and to hear about a little bit about how you use Python in your own work. Now, I also want to share with our entire audience that you too can become a host panelist. If you would like to join us up here on stage, please do reach out. Our email is doepy@dutc.io. Now, let's jump right into our coding activity. And today's coding activity is called When Do I Want? And here are the rules. In order to play, or how to play When Do I Want, we want to explain sophisticated programming concepts to scientists, but how do we motivate them to include these concepts in their own work? Well, our panelists will be presented with an advanced feature of Python that might come up in some of the code that you write. Then we'll try to explain why that feature might be desirable in a given piece of code. And finally, we're going to score our panelists, not really, on the specificness with, of course, bonus points for relatable anecdotes and experiences working with scientific researchers. And so in our first round of When Do I Want? We're going to ask, well, when do I want to use a set or a tuple? And for a bonus point, when would I use a list? And so I'll open it up to our floor and of course to our audience to chime in through the chat. When do I want to use a set over a tuple?
I guess I'll break the impasse. If you want to check whether an item is in a group, then set is much faster than walking through a tuple or a list where you have to check everything one at a time. And when the collections get large, that will get slow.
I'd also say if you want to change it, you wouldn't want to use a tuple. You want to use a set, as in sets are not immutable.
Mm-hmm. Right, so tuple doesn't like appending or append-like operations. We would have to construct a new one.
Yeah.
Yeah, I think I also wanted to add something here in terms of, for example, if we would like to do something specific that may come automatically or like a bit more integrated with sets, we would like to, for example, find duplicates. We like to have like union of components without necessarily having to deal with those duplicates. Depending on the scale and how many elements we'll have in that set, then perhaps we might consider that, as the name may suggest, sets can handle those things.
Mm-hmm. Yeah, I would absolutely agree with all the answers we've had here so far, right? So sets are machine ordered and unique entities, meaning I can't store two of the same object within a set, whereas I can in a tuple. And The sets are great for kind of our classical mathematical set notation. If I wanted to find all of the distinct items across two sets, I can very easily do that. Or if I want to find the distinct items in one set that's not present in another, we can do that as well. Whereas tuples I'll use usually for data structuring, and you can think of a tuple very classically as representing, right, a single row in a table or a single row in a database. It's used to represent heterogeneous features of a single piece of data. But before we go on to the next round, I did want to open it up to our panel. Any final thoughts about the distinction between our set and our tuple? Or does anyone want to go for the list here? Maybe a tuple versus a list?
Mutable, immutable is the thing that people often think of first. A sort
Ordered.
of
Well,
Good.
ordered for a tuple and set is not.
Mm-hmm.
Yeah.
Dan, I like that train you were on just now, the mutable versus immutable. Was there anything else on that, or was that pretty much it?
The fact that you can't append to a tuple and you can to a list kind of suggests how you're supposed to use them. For a
Mhm.
list, it's this group of things that you might be looping over, and they're probably similar. Maybe they're not exactly the same type because this is Python and YOLO. But usually you're doing a loop over a list. For a tuple, it's more like a record, like a row in a table. And rows don't usually change size, so it kind of makes sense you're not mutating them. And it might be something like a coordinate X, Y, where the meaning of each item is a little different. Whereas in a list, usually the meaning of each item is the same. They're just different values.
Yeah.
That's the
I think-
vibes.
Yeah. The other thing I would say is you may want to, if you wanted to sort, you'd want to use a list because you can sort a list, but you can't sort a set.
Mm-hmm.
Yeah.
Yeah, I think these are all fantastic points about when we would use one over the other. Now, let's go on to round 2. In this round, we'll go beyond the basic built-in Python data structures, and let's ask, when do I want to use NumPy or Xarray? Any thoughts from our panel?
The first one is multi-dimensional. Well, I was going to say multi-dimensionality, but of course,
Yeah, both multi-dimensional.
I know that's what I was trying to.
Do you want to label your dimensions?
That's what I was. Yes, I was. It's thanks, Dan. I was. It's. Yes, I always think of X-array as like a, I don't know, a multi-dimensional pandas. Yeah, I know that.
And it's interesting that you say that because a lot of the work that Xarray originally was doing was being handled by pandas. This is the pandas panel object that got deprecated ages ago. And then they decided and finally said, you know what, if you need a panel object, either use a multi-index in pandas or go use an Xarray because your data is actually multi-dimensional and not hierarchical two-dimensional.
Isn't panel what pandas was even named for? And then they removed the feature panel data analysis. I think that's true.
Yeah. And then they said, you know what, anything beyond, I'm going to use the phrase two dimensionals loosely here, but anything beyond two dimensionals is just out of scope for the project. And as we've all, if we have used pandas, we know its API is quite large. So I think this is a sigh of relief from the entire world. But I personally agree with the answers we've heard so far. If you want to have labeled dimensions to your n-dimensional arrays, Xarray is going to be where you want to go. And probably the easiest example I can think of is if you load in an image, right, into a multi-dimensional array, is the ordering of your dimensions, do you have red, then blue, then green? Is it GBR, RBG, RGB? And it's almost impossible to tell unless you dig through the documentation for the tool that loaded it in and then figure out from the documentation what you're dealing with. And so if we had labels to each of these dimensions here, then we could probably more easily tell which feature is which. Any other thoughts from our panel on NumPy versus Xarray? All right, then let's jump into our third round. Back to base Python. When do I want to write a function?
My sort of flippant answer is when you find yourself doing the same thing again and again and again.
Mm-hmm.
I had a reason to ask someone to do this today, which is maybe not the usual reason, which is I'm not sure the code is going to be reused. And sometimes it's easier to just put the code in line anyway. That's if it's short. But the code was sufficiently confusing about what it was supposed to do that the reason I wanted it to be a function is that the function would then have to have a name, which would help explain what the code was for.
Mm-hmm. So functions almost like documentation in and of itself, a little bit better than just a comment, right?
Yeah. The name gets you pretty far. You know, it could also have a doc string. It could also be separately unit tested. These all things help people understand what it does even more. But even just naming it as a
And you
as
can
a
see where it
discrete
starts
step.
and ends as well. You know, it's the,
Mm-hmm.
Yeah, I think even from
Yeah, that's a good point.
data science as well perspective as well. I mean, you could have very well written code that it's just a massive block of code that goes around, for example, data pre-processing, whatever model is applying, training procedure, prediction procedure. But it will be very difficult, for example, to both document and to be able to reutilize probably some pieces of this code in some few other techniques. So probably on that sense, breaking these down by steps where each of these steps is a function, regardless of whether, I mean, it will be great if this could be reused, but even if they are not, just for the sake as well of being able to test, to be able to separate these pieces, to be able to follow the code a bit better within a data science perspective, although it's not fully exploited sometimes, it is great to see these pieces breaking down in some sort of convention function will be great for those.
Yeah, absolutely agree, right? It helps us write some simple scripts, but it also helps us keep track of what each component of that script is actually doing. And usually if you can read through some of the code that you've written, once you're at that function level, that bottom portion of your script, you can say, oh, I'm doing this data pre-process, and then I'm analyzing, and then I'm creating a visualization. That could be 3 separate functions. Anything else for when do we write a function? I want to just take one moment and reiterate something that Stuart said. It was whenever you catch yourself kind of repeating the same chunk of code. And I think that is a very important point to make. And one thing I wanted to add on was we want to make sure that we're capturing intentional repetition. Because if I have some function called process file, and then all of a sudden I run it on all my files and I realize, oh, you know what? That one file that needs to be processed differently. And then I go into my function, I say, if file name is, a.txt, do something else. And then all of a sudden you start embedding all of these modalities within a function. You might be asking yourself, wait a minute, did I actually want to do the same thing to every one of these files in the first place? Or was that just an oversight on my part? And so that's one of the additional things I would say about the repetition. But of course, whenever we're intentionally repeating the same elements of our code on different entities, function is going to be a great way to go.
There's a great way to pose that exact observation that Nick Coughlin put in a blog post once, that when you're refactoring to avoid repetition, you want to be thinking about whether the evolutionary pressures on the different places where that function is used are the same.
Yeah, that is a great way of phrasing it. Dan, do you think you could share that blog post with us in the
I saw
chat?
that in like 2013, so I probably cannot, but I will try.
We'll have to dig through the archives. Well, with that in mind, let's go to our next round, which is going to be related to when I want to write a function. When do I want to write a decorator? And when do I want to use a decorator?
to change how a function behaves.
Yeah, you've probably seen a lot of these with Fast API, right, Stuart?
Yep.
Define your endpoints. Any other uses? Tanny, have you ever used decorators just from any Python package you're using, not necessarily ones you've written yourself?
I mean, within the web development side with Dash, Plotly, those are very common. And I think they're very useful as well. I mean, if we want to give our functions a bit more of a flexibility, I think I resonate in this case with what Stuart mentioned before. And I mean, yeah, we see them a lot nowadays in very few Python packages. Dash plotly, for example, is one of the ones that comes to mind.
Yeah, and what's kind of the sample used? I know you define like outputs for Dash plotly.
You also have like callbacks. So you will be defining like, a callback will be the decorator, and you also have long callbacks. Whenever the output may take another a considerable amount of time for a regular callback to handle that. So you can define several different type of outputs or amount of outputs, your inputs and your states. And then you will write, in this case, the function or the callback that will react to such inputs and what they will be reporting back. So very flexible, really great, and easy in this case to integrate as well with existing code that is Python based.
Yeah, I absolutely agree with you. And I did want to hear, Dan, have you used any Python packages that regularly use decorators?
Yeah. I was trying to think of anything I could say to complement what Stuart said, but I can only think of more jargony ways to say the same thing. Take a function, change the way it behaves. I guess to get, but
no, I was going to say my favorite one, I think, because I'm generally a lazy person, is, the magic one where I've got some computational thing, I want it quicker, is @JIT from numbers.
Yeah,
zero,
boy, that really radically changes the way a function behaves.
Just a little bit.
In an example from the X-ray synchrotron world is in Blue Sky, when you have a scan and you want to make that scan take place on relative coordinates rather than absolute coordinates, the difference between what's spec called D-scan and A-scan, that's the decorator.
Nice. There's a lot of usage of decorators, and Stuart, you took on the tricky part of, well, when do I write one in the first place? And you said it can modify the behavior of a function. And we see a couple of different usages for decorators, and I think that's a very important one to identify. And going back to our Fast API, or even our kind of Flask-like examples where you defined endpoints, we're not necessarily changing the behavior of that function, but we're registering it right to the application itself. So I see decorators used a lot as kind of an API design decision, right? How do I want my users building or interacting with my code? But I would also say that we would write a decorator. Since it works on functions, we can also use decorators for classes, right? Think of a data class. We want to use these tools whenever we're writing a lot of functions. If I don't have a lot of functions, I probably don't need a decorator to modify their behavior or anything like that.
True.
All right, let's jump into our final round here. When do I want to write a generator? No more returns, just yields. And it's a real shame that James isn't here to join us today, because James has probably written a dissertation about generators in Python. But let's hear what our panel has to say.
Well, according to what I've been told by Tom Caswell and Dan Allen, all the time for everything. Should I not?
I was waiting for that. Yep.
Sorry, I was trying to resist it, but I thought, why resist?
So there's a good example that James has taught us that I think is easy to understand. It's in SciPy, when you're doing curve fitting data to a model. You have to tell SciPy up front how close you would like your fit to be, like absolute tolerance or relevant tolerance, or you could imagine some sort of chi-square. I don't even know if that's an option. And the point that I've heard James make is that anticipating all the different conditions that the user might want and adding those as optional arguments and then documenting those arguments and blah, blah, blah becomes really onerous. With a generator, if SciPy had made a different design decision to use generators, they could yield the state of this converging process one at a time, and then move the decision of how long to continue and what to do about it and what you're observing outside the function, by giving the function the opportunity to provide results more than just once at the end, but many results. You're externalizing that decision making. And then you can make n different versions of this that expose different parameters in different ways. I think that's a really strong, scientifically motivated example.
Yeah. So if we have like some long running computation and it's discretized into a number of steps, we can yield each of those steps out, and then it's up to the user if they want to keep on computing and not up to our own internal assumptions about how long the compute should happen, or like Dan said, exposing 80 different keyword arguments to say that, well, the computation should stop here. So I think
despite the fact that this is recorded, no one who works for DUTC on stage or backstage should ever let on to James that I remembered anything he said, just to be clear.
And he had no impact on why Blue Sky uses generators.
Not at all, none.
No. Any other thoughts on generators? I have one more use case. Is when I personally will write a generator in my own code. It's when I'm feeling lazy and I don't want to decide if I should return a list, a tuple, or a set from a function. Instead, I'll just yield out each element and I'll leave it up to my end user or myself in the future to unpack that generator into a list or unpack that into a tuple, depending on what data structure I actually want for my result. So if I can't come to a reasonable decision, I just save myself some headache and maybe some future headache by just saying, you know what, it's a generator. I'll just yield out each step. All right, that takes us to the end of our coding activity here. And so I would love for us to gather around for Stuart's prepared remarks, where he'll be sharing on some of his career and all of the amazing things and the amazing tools that he's had to work with in the past. So Stuart, please take it away.
So that I'd like to thank you for inviting me to speak today. I must admit I did rack my brains quite a bit about what I should talk about. So and then I thought, so this is really going to be just some of my things that I've come across when working with not necessarily just Python projects, but projects across as a whole. So just quickly, who am I? So I thought every talk now has to have something about AI ML in it. So I asked ChatGPT to describe the village I grew up in, and I thought I'd just put it here because I think it firstly had the word quaint in, which is always a word that's not used enough, and then it's got pubs and shops and things. So it's this is in, if you can't tell from my accent, I grew up in the UK, and then I went to university in Salford in Manchester, and there I did my degree and PhD. And my PhD was basically in hydrogen metal systems and also designing of neutron scattering beamlines. So then after that, I went to become a staff member at the ISIS Neutron and Muon facility, which is at Rutherford Appleton in Oxfordshire in the UK. And there I basically was working on scientific computing. And so this is where, I'm sure people know the Nexus file format. So I started working on that at this point. And there was also a collaboration we had with the neutron source Argon called OpenGenie, which was a sort of IDL MATLAB type thing. If we wrote it now, it would all be in Python, but at the time, that wasn't really an option. And then I moved to Diamond Light Source, which is on the same campus as ISIS facility. And there, again, I was involved with a lot of the design of the initial computer system, but my main job there was I was a developer for the Generic Data Acquisition Program, which is the GDA, which was a collaborative project between the synchrotron that was closing down at Daresbury Lab and also at Diamond. So in 2008, I moved to Oak Ridge National Laboratory, where I worked at the Spallation neutron source. And here, this is where I worked when the project I'll talk about my experiences on, so I'll just skip over it. And then about 6-7 years ago, I moved to Brookhaven National Lab to work within the NSLS-II with lots of great people like Dan. Right, so looping back to my time at Oak Ridge National Lab. So I thought I would focus on one cross-lab project that I worked on called Mantid Project. So just a bit of background what actually it is. It's a framework for doing data reduction, data analysis, visualization of primarily neutron scattering data, but there's nothing that stops it for any scientific data. It was cross-platform from the outset, open source, and it was primarily written in C++ with a Qt front end, and it had Python and high dimensional visualization with ParaView. The labs that are involved was the ICES facility, the European Spallation Source, which is in London, Sweden, Paul Scher Institute, and the ILL were all partners. And so it was across many labs. So just to go back to why at the SNS, we started to even be involved with the MANTID project. When the spallation neutron source turned on in 2006, all the beamlines that were first built as part of the project were actually very low data producing beamlines. And so the sort of scientific software libraries that were built in order to process the data didn't scale as well when the larger beamlines started to come along. And so that picture at the side is the Sequoia beamline, which is a 2.5-story high detector bank. And so these start to produce lots and lots of data. So we had to start to look around, for what's the next version of that data processing software. And so then we heard of this thing called MANTID, which was being developed at Rutherford Appleton Laboratory. And so we thought, we should reach out to the developers. And there coincidentally was the International Conference on Neutron Scattering in 2009 in Knoxville in Tennessee, which is near Oak Ridge. And so we had initial discussions then. And then I went to basically visit Rutherford Appleton, and with my sort of personal background there, basically go around and see if we could, what the real story was by talking to people and, is it any good? Should we be involved? And to basically sum up what our thinking was that, we thought it's going to be more fun to do our own solution, but it's probably the right thing to do to join the collaboration, and we could do more together. And so then we joined the collaboration. So what did I do in the project? So I was the main contact point to the overall project manager. So, within the project, we had a single project manager that spanned across all the laboratories. So for Oak Ridge, I was the sort of local project manager. I also was the chair of the technical steering committee. I was a team lead, so I had developers that worked for me. I was a developer myself, and I set up all the build infrastructure as well. So I would say, the first thing was to try and, when you're working in a collaboration like this, is to try and, learn from other people that are doing also collaborative projects. People have distributed workforces across the world. We're not the only ones. So basically find good ideas, steal them. Communication is, very, very important. And so, having everyone on the same communication tool, so something like Slack is important. We moved towards, we had, a single source code repository, having defined coding standards. One thing we found very useful, which was originally in the project, we had like owner listed for every file. And we found that people seemed to be reluctant to edit files that were owned by somebody else. And so we basically went through and removed the owner of every file. And we saw an uptick in people editing files across the project. So basically, act as a single developer team. One thing that we were very deliberate about was trying to build those personal connections across the project. We found that, even with us all used to online communications and social media, it's very easy to misread, misinterpret something somebody says in a chat channel or an email or something, if you don't really know them. If you do know them and you have a personal connection, you can see beyond, a a short or a very what could be interpreted as a unfriendly comment if you actually know that person. So to go along the lines of this, building personal connections, and I don't want this slide to make you think that I just spend all my time drinking coffee, but I think it's very important to sort of have these discussions with people that are not in formal meetings. So I think a lot of the time, the sort of, I'll say, more informal aspect of communications is very important. And, there's lots of problems that are solved or, averted by, people going out for coffee or beers or dinner with each other. So one thing I wanted to show was, and, I know that, the number of issues or tickets completed in a bug tracker is not, a good measurement of the amount of work done. But this was basically the issues in the Mantid project that were done, as you can see, when ISIS was alone, and then when ISIS and SNS were, basically getting their act together to perform as a single team, and then afterwards. And the level afterwards is more than double the ISIS one. And so I think this showed that, you can actually, if you work well as a team, that benefit you get can be multiplicative. One thing I remember us talking a lot about is release timing. And, when you've got a software project at a single facility, it's pretty easy. Generally facilities have some sort of downtime. You can release software during downtime, you can deploy it. But when you have multiple facilities, it becomes virtually impossible to find a common time that's suitable and convenient for everybody. So, basically my advice is, don't try to spend time finding that, just pick a fixed release schedule and then let the facilities themselves, decide when they're going to deploy it themselves. So basically you separate out the release schedule of the software from the deployment and the local installation. The other thing that, and this in particular was something that was a source of lots of, I'll say, friendly discussions, that there's often I see it in a lot of places, there's often this sort of assumption that not changing things equals stability. And I don't think that is always the case. You do have to move with the times. So, I've just put here, like with the GDA project I worked on Mantid, there's various changes we had in source code repositories, issue trackers. But also, I think a lot of these sort of developer tools, it's important to actually listen to the developers and what they want, because if you pick a tool that they hate using, then they won't use it. So, it's better to, and we saw this especially in the Mantid project when, basically a lot of the developers wanted to move to GitHub. And so people stopped really doing as much in track, until we moved to GitHub. And so my first slide with the word Python on it. So I apologize, it's taken me so long. So as I said in the first slide on Mantid, Mantid was written in C++. And actually at the time that at Oak Ridge became involved in the project, that actually wasn't a Python API. And the project at the time thought that scientists would write C++ code to extend and to coordinate workflows and things within the project, which we didn't agree with. And so, that was one of the first things that we wanted, to be changed in the project, to actually have a Python API. And I must admit, the first API we had was not very Pythonic and was basically, one module, you import it all, and there you go, you get everything. And so I would say that the way that we basically use semantic versioning to, indicate when there's a breaking change. So we would, change the major version of Mantid when we would change the Python API and things like that. And so really, there's been 2 or 3 major changes in the Python API, and it's something that we took a lot of effort to communicate with people, and so we would detail what was changing, why we were changing it. Every time we did a release at each of the facilities, we used to do like a presentation to the local scientists, and we would basically just keep repeating what was changing, why, and the timeline, and lay out the expectations. The other thing that we did was we created a scripts GitHub repository that, if people, we said, if people upload your scripts or your Python code, that we will basically go through and convert it for you. And then we also made a tool that would, along the lines of, that would be shipped with it, Manted, as soon as we knew what the changes were going to be, that would, do a good first pass. So I would say, coming to the end, that it's very clear that facilities, within the DOE complex and worldwide, software is become something that's mission critical. And I've just listed some characteristics of what software has to be, but I think to get these projects, you do need within the organization, vision, resources, which is sometimes not always easy to get. And I would say, above all, you need developers and leadership that would support these projects. And any facility can probably provide all these themselves, but most are not used to doing it. So it's much better to work together, and to end on a nice, happy note. I think we're all better if we work together. And that's really all I had to say. Thank you.
Fantastic. Thank you so much, Stuart. And so now we'll go ahead and open up our Q&A panel. So if you're in the audience, you have a Q&A widget that you can enter your questions into. If you have questions for Stuart and then you want to get to know him better, or if you have questions for Stuart about some of the Python code that he's written, or maybe the IDL or MATLAB code he's written, then please do enter that in the Q&A widget. And I will now open up our questions to our panel. So Dan and Tanny, do you have any questions for Stuart?
I'll start. I was interested in the story about removing owners from the files. I don't think I'd heard that before. So that's the case where there's some sort of boilerplate at the top that says Dan was the first person to write this.
Yeah, like at author, whatever, in like the in the documentation within the methods, the functions, the files. And yeah, it was something that I must admit I advocated for, that shared ownership of the code. And the whole thing is, if you've got enough test suite and test coverage, you shouldn't be afraid to edit anything, because you should soon know if you've broken something. And
I had a reflexive dislike for that when I saw some people do it around BNL, but it was mostly just like, well, that's not how I see people do it in Matplotlib or in Pandas or something, and this idea of shared ownership. But I didn't have a specific argument against it. So I think it's really interesting that you have data that shows even just having it there will make people differential in a way that's harmful.
Yes, because especially if they saw like one of the senior developers had written this, they'd be like, well, I can't do it must be perfect. I'm not as good as that person. And they would be very reluctant to, which is not the case, but
or even if they think they could do it better, they may worry that the suggestion wouldn't be well received.
Right. I think I have a more of a kind of like a management kind of like side of things, in terms of, for example, keeping up with like a large scale, in this case, team, potentially with a variety of different backgrounds. How does that look, like the top level? Like, how do you keep everybody involved within the process? Talking more about like human resources management front.
I think partners, a nice, easy question. Thank you. I think I think a lot of it is, you just need to get to know, take the time to know the team and the people and what their strengths are, what their weaknesses are, what they like working on, what they don't. And, and then sort of, in an ideal team, you'd always have a nice, distribution of those people who want to do them all. I'll say, algorithm, mathematics, and science tasks, and those who want to run, this continuous integration system. And you're never going to get that whole thing, but is to try and sort of steer people and give them tasks towards their interests, basically, because that will help them grow, and that's where their interest is. And at the same time, to give them the opportunities to learn and develop their programming. So one thing that we did try to do a lot was like code reviews. So mainly, as I would say, the code reviews were more as a learning exercise for everyone else in the room, not to review actually the code that was being reviewed. It was more, oh, that's how you do that, or oh, why did you do that way? And so to sort of act that keep so it becomes a training thing without people realizing it's a training thing. I don't know if I've answered your question and just rambled on, but
No, absolutely. I think that's kind of,
sorry.
So that's kind of like what I had in mind as well, in terms of especially kind of like in terms of both like code review and continuous integration of code. If, for example, if there'll be like existing templates as well of I don't know, either architecture wise or code style, documentation style as well, since that can, but I mean, every documentation is precious, and that I think it's agreed upon anybody that writes some code, but once it becomes a standard practice among a very large team, different styles of documentation, even as well, overall just documentation in general, it can become a bit more complicated on that front.
Yeah, and I would say that the one thing that we tried to do across the project was those really dull tasks that nobody wants to do, like, I don't know, going through and making sure you've got coverage of all your documentation, like Java type docs, that you just share that out across the entire team. And so we used to pick a day that was like function documentation day, and everyone would be allocated a certain portion of the code base, and you'd do it, but it was a shared pain on a day rather than one person getting lumbered with doing it all the time.
Makes sense.
Now, we do have a question in the chat for Stuart, but of course, either of our panelists, please do chime in. And I think this is in relation to the type of data that Mantid works with, but the question asked, which data visualization tools and libraries would you recommend?
So I'm always contractually obliged to say matplotlib, because Tom would kill me otherwise. But no, so yes, within like Mantid, we used multiple libraries. So, but I would say the main two was like VTK, PowerView type things for multi-dimensional data sets. There's one thing with some of the data we were doing was we're collecting in 4-dimensional space, and it's very sparse. And so, to be able to do cuts and slices and things, and PowerView and VTK is very good. But for, I'll say simple plots, matplotlib is pretty good. Although, yeah, I'd leave it at that, to be honest.
Dan and Tanny, what about, what do you all use for your work for data visualization?
I wish I had time to visualize much data nowadays. Yeah, creature of habit, matplotlib.
Mm-hmm.
I mean, I agree. For the most part, when it comes to machine learning based algorithms, and I need to really quickly check on results, I will use matplotlib. But since we, as a group, are looking more into the visualization of data on the web, then we do have a combination of frameworks that we use for that. For fast prototyping, for the most part, we use Dashplotly. But yeah, those are some few frameworks I think that I can mention at the moment, but more to come, of course.
And I'm curious, Tanny, how has the transition, or not transition so much, but what do you like about the contention between Plotly and Matplotlib? When would you choose one or the other? Or is it just if I want to do something on the web?
I think it also has something to do with how dynamically I want to interact with the graph that I currently have. I honestly, I think for a publication, maybe I would look more onto Matplotlib because I would like for the graph to, or for the plot not to move at all. That's kind of like intended. And if I need to annotate it or anything, I can do it. I can do so very precisely. But if I would like for have more a dynamically plot where I would like to zoom in and be able to visualize different parts of it, move things around, annotate on the spot, then maybe I would look into Plotly instead.
Absolutely. And Dan, I know what you were feeling when you said that you wish you had the time to do some data visualization. And honestly, when I was in graduate school, I wasted a lot of time doing data visualization when I should have been writing, right? I was working on my paper, and instead of, fixing that sentence or fixing that paragraph, you know what? I think that one part of my data visualization, I just need to move it, maybe a few centimeters to the left. And so data visualization does have a way of creeping on your time.
Yep. My 30,000 points on Stack Overflow don't count toward my H-index for publishing, unfortunately. That's where my procrastination time went. I wanted to remember on visualization to name drop Napari also. I do play with Napari a little bit, and we have some scientists who've been checking it out and happy with that.
Yeah, actually, Tanny, have you done multi-dimensional data visualization with Plotly, or do you just usually do kind of 2D and then maybe if you have some widgets that could help you peruse through other dimensions?
Right, mostly, at least for the pipelines and the workflows that I have worked on, we only visualize two-dimensional data sets. But there are some ongoing efforts within our team on being able to visualize larger or large-scale multi-dimensional data sets. But I think out of the box, if I recall correctly, there is not full support on that front, at least from Plotly. But there are other frameworks out there that can be used for that. They have a lot more capabilities in order to be able to visualize three-dimensional data sets. Napari, the one that Dan mentioned before, has to some extent some capability on that, even for labeling, which is why it's very, very popular, I think, nowadays within the data science community.
I think the other thing that sometimes you need to take into account as well is the size of the data, because if you can do a plot, in Matplotlib and ship a PNG, if you try and load a lot of data into Plotly or any of these web, you can have pain as well. So
yeah, I've done some work with someone. They want to switch to Plotly, but whenever they naively try and just throw a lot of data, like a very large data set, into their interface, it just freezes up their whole web browser. And you're saying, well, yeah, Python keeps the data in process, and then your visualization doesn't need to hold on to all that extra data. You wouldn't be duplicating it right across two sources, and then you just see the PNG nicely rendered. And so I think that's a great point, because I don't want to give the appearance that Matplotlib cannot do anything with the web browser. Of course, you can always ship a PNG to your web browser. That's how your Jupyter notebooks work. Whenever you see your output in your notebook.
At the SNS, we used to have monitoring pages, and the scientists could we'd either use Matplotlib or Plotly, basically, to either ship a JavaScript blob or PNGs or both into pages, and just and it was exactly as Tanny said, it was the interactivity. If you wanted to zoom in that, you'd use one, or if it was too big, you'd just give the PNG.
Now,
one
Tanny,
that I'm really
yeah,
interested in. Oh, sorry, go ahead.
Oh, please go ahead, Dan.
Okay. One that I'm really interested in but haven't even played with. I'll put a link in the chat. Maybe Cameron, you know how to propagate that. Vega Fusion by John Meese. It's like, I think, a little less than 2 years old. That's right. It will intelligently, dynamically decide whether it should do math in JavaScript for quick, responsive, click and drag things, or do math on the server if the data is huge. So rather than forcing you to choose, it will use existing Apache projects and JavaScript projects and stuff to either do the computation in Python or in Rust on the server or in JavaScript on the client. And you don't have to know any of this is happening, but it's kind of the have your cake and eat it too approach. And I don't know what its
It's too good to be
limitations are
true.
because I haven't tried it, but it's pretty
Yeah.
cool.
Sounds too good to be true.
Yeah. We'll see.
So just go to their GitHub page, open up their issues, and then that's where I always start whenever I look at a new tool. I'm not wondering what
This
it
is
can
too
do.
good to be true.
Yeah, but what it can't do. Either that or go to Stack Overflow. But yeah, Vega Fusion sounds like a very interesting.
Cool.
And right, that's Vega is the backend behind Altair and Python, right?
Right.
Awesome. There's also, for large data sets in the browser, there's Data Shader, which has come out of the HoloViz suite. Now, Tanny, have you ever used Data Shader for some of your data sets?
We did try to some extent integrate some of that. Right now, actually, we are tackling this from a different perspective. Instead, we are trying to further integrate at least the data access section, or to kind of like offer users to be able to have some data access techniques, including tile, from the Blue Sky project. And that's something as well that some of my colleagues are working on very actively as well. And that has actually helped us further integrate larger data sets on our web browsers base. But yeah, some few of my colleagues have been working on that a lot more actively. That's something that we're looking into. We did try Data Shader. It did not work out at the time as well as we expected for other reasons. But Tile has been great in order to achieve that on the web browser.
Awesome.
And we haven't paid Tanny to say that.
So we should share also the link to Tile.
Oh, yes. Now, I do have a follow-up question because we're talking about a lot of moving to the web. What's wrong with my little graphical user interfaces on my own local computer? Why move to the web?
I mean, I think it really depends, right? It's like, I think overall the bottleneck may come onto what type of requirements do I need in order to expand, for example, my user interface in my local machine. And whether we would like to, I think it also depends on what the target audience will be, what our community, that our users will be. Because if they span across many different, if they need very different requirements in order just to install a, in this case, a working UI in their local machines, that may be a bit more complicated. Instead of, I think the easiest way is just to go to a website and start integrating them and playing things around on that website. So I think it minimizes also the preparation on the user side of having to install something, deal with requirements with the GitHub repo. It's just a lot easier just to go to a website. Of course, it has its pros and cons in terms of like having a bit more access, I guess, like to larger data sets, as we were talking about. That's one of the major kind of like bottlenecks as well on these implementations. But it's something exciting, and I think it's also exciting for users to be able to have access to this on their browsers.
I would agree, but from the other side, not the user side, but the developer side, maintaining a cross-platform GUI application with installers and debugging and every version of Windows, Mac OS, Linux, whatever that anyone wants to try, is not an insignificant effort to keep it up to date. And so laziness
Absolutely.
is my answer.
Yeah. Simplifies your life. Simplifies everyone's life, right? Findability or searchability for your end user, and then also your own development, right?
And there are nowadays you can still use web technologies and web and ship them locally. Like VS Code. It's it's all JavaScript.
Yeah. And I think you can even use that Electron apps as they're usually referenced.
Yeah.
But I think there's a package in Python that also lets you develop them. I want to say it's called Eel. But if you're looking to develop browser-based native-looking applications in Python, I should say, then definitely give that a check. Now, I did want to just ask, any final thoughts or questions from our panelists before we wrap up here today?
No, just thank you very much for.
Fantastic. Well, thank you very much, Stuart. And I have to say, this has been a fantastic exchange. And I also want to extend a huge thank you to our audience for joining us this month. If you're not already signed up for our newsletter, make sure you subscribe. The subscription link can be found on our website. And again, that's meetup.doepy.org. Or if you don't like receiving just one email per month, make sure you keep a regular eye on our website for information about upcoming exchanges like the one we have later this month. And now, speaking about our next exchange, we will be joined by Katrina Reel, who serves as the president of NumFocus, the 501c3 nonprofit, who sources funding for many of the Python packages you use every single day, like Pandas and NumPy and Matplotlib. She's also the head of the Streamlit data team at Snowflake and has nearly 2 decades of experience working in the fields of scientific computing, machine learning, data mining, and visualization. So make sure you join us later this month because Katrina will be a guest panelist that you don't want to miss out on. Thank you all again for joining us, and I hope to see you next time.